Alrighty, guys, your answers from last night's homework. This guy, his initial value would be 2/3. It would be a growth because it is bigger than 1 in the parentheses, and specifically the growth factor would be the number in the parentheses, in this case 3. All right, for this next one, the initial value is 2/3 again. It is a decay because the number in the parentheses is less than 1 or trapped between 0 and 1. And the decay factor is whatever that number is, in this case 1/3. Next one, my initial value is 3/2. It is a decay because the number in parentheses is smaller than 1. And the decay factor is whatever that number is, in this case 2/3. All right, we did that one together. So I am on question number 3. So when you breathe normally, about 12% of the air in your lungs is replaced with each breath. So we need to write an equation here, write an explicit equation for the sequence that models the amount of original air left in your lungs, given that the initial volume of air is 500. So 500 is my initial amount. And because it's my initial amount, that means I'm only going to use n or t for my exponent, not the -1 part. It loses 12%, so I'm going to say 1 minus 0.12 for 12%. And then my exponent again would just be n or t, whatever you prefer. So that is our explicit formula. And then let's use that model to determine how much of the original remains after 50 breaths. So to our calculator, I'm going to say 500, 1 minus 0.12, and we're going to raise that to the 50th power for 50 breaths. And it looks like 0.837 or 0.84 if you prefer would be left. So let's call that 0.84 milliliters would be remaining of that initial amount we took in. Alrighty. Ryan bought a new computer for $2,100. The value of the computer decreases by 50% each year. When will it drop below 300? All right, let's first write us an equation. So the initial amount was $2,100. 1 minus the amount it's losing, 50%. And then again, because I'm using the initial amount, I'm going to raise it to the power of x, t, n, whatever it is you like. And when will it drop below $300? So again, what I'm going to do is take that to the calculator and I'm going to graph it. I feel like that's an easier way to approach it, but you can use guess and check again. And then I'm going to go to the table and see when does it drop below 300. Did I put 1,200 in? Yes, I did. Or 2,100, sorry. So it looks like it drops below $300 in the 3rd year. So in 3 years. Alrighty. Kelly's mom takes 400 milligram dose of aspirin each hour. The amount of aspirin in her system decreases by about 29%. How much is left? So let's start off writing us an equation. A sub n, that equals her initial amount for 100. 1 minus the amount she's losing, 0.29. And then because, again, I'm using the initial amount, I'm going to raise it to the power of x, t, or n, whatever you like. And how much is left in her system after 6 hours? So I'm going to take that to the calculator and plug a 6 in for n. So 400, parentheses, 1 minus 0.29. And raising that, did I say 6? I forget already. 6, okay. So it looks like 51.24 is still left in her system, 51.24, and what is that in milligrams? Alrighty, those are your answers. If you would like me to go into them more in depth, please feel free to email me, hop onto Google Hangouts with me. I am going to have you hop down. We're going to skip this next problem, so let's just skip those next pages there. All right, and I want you to go to where it says problem set. Now, everything that says graph, I want you to get rid of. I don't want you to have to do any graphing. So any part that you see that says graph, you may get rid of. I am going to also include this in the notes section so that you have this to look at. So please use it if you need it, but go ahead and get through the rest of these problems. And if you need anything, make sure that you let me know. And I hope all is well.